Matrices. There are three main topics that you need to make sure you understand for matrices. 3.5. The first one is making sure you understand the dimensions of a matrix. For example, this matrix right here, what I like to do is I start at the bottom corner and I just count kind of like slope, up and over. 1, 2 up and 1, 2, 3 over. So this is a 2 by 3 matrix. This is also a 2 by 3 matrix. This is a 2 by 2 matrix. Now, the second thing is adding and subtracting matrices. There's a major rule that you have to keep in mind. To add two matrices, they must have the same dimensions, exactly the same. Can't be different at all. These two matrices have the same dimensions. So, what I have to do is I want to add corresponding values. What does that mean? Well, I started with a pair of 2 by 3 matrices. I'm going to end with a 2 by 3 matrix. And I'm going to add corresponding values. 6 matches or is corresponding with the 2. So add them together. 6 plus 2 is 8. Negative 2 plus 3 is 1. 4 plus negative 6 is negative 2. 1 plus negative 5 is negative 4. 5 plus negative 3 is 2. And 3 plus 8 is 11. And that's how you add or subtract. Be very careful if it is a subtraction. The minus sign goes to each and every value. Now, another partial concept that we have to cover is scalar multiplication. Very simple, very easy. Just be extra careful sometimes with distributing. We're going to multiply each number in the matrix by the given value. 4 times this matrix means I'm going to multiply each number in this matrix by 4. So, 4 times 6 is 24. 4 times negative 1. 4 times negative 3. And 4 times 2. That's it. Now, we could combine some of these and have, for example, 2 times 1 matrix plus or minus 3 times another matrix. But you've gotten some examples of that on your assignments, and we can do some more of those in class. The next topic that I want to go over, though, for you to review is matrix multiplication. When looking at the dimensions, the middle numbers must be the same. So unlike adding and subtracting, we don't need to have the matrices the exact same size. Matter of fact, sometimes being the exact same size won't work. What's important is that the middle number is the same. If I'm multiplying a 2 by 3 matrix by a 3 by 4 matrix, these two middle numbers are both a 3, so that can be multiplied. But if I switched places and multiplied the 3 by 4, then times the 2 by 3, order is very, very important. These middle numbers don't match anymore, and it cannot be multiplied. All right, now, I'm showing a lot of steps that we don't normally show, but I wanted to show every little bit for you for the video. So, if I take these two matrices, they're both a 2 by 2, and so let's write that out. A 2 by 2 multiplied by a 2 by 2. Oh look, the middle numbers are the same. I can multiply them. So what I'm going to do is I'm going to start with one step. Keep in mind, in the first matrix, we're always multiplying a row, and in the second matrix, we're multiplying it by a column. Okay? Row times column, row times column. So here's my first step in green. I'm going to take the first row and multiply it by the first column. Multiply the first row times the first column. Again, we're going to compare corresponding parts. There are 2 numbers in this row. There are 2 numbers in this column. The first number and the first number get multiplied together. 2 times 4. Now, I put this over here. Okay, the green corresponds to the first one. I'm going to multiply 2 times the 4 and 7 times the 5. And I'll show it to you this way. 2 times the 4, 7 times the 5. And I get 2 times 4 and 7 times 5. Now, I need to multiply the first row times the second column. So I showed that over here in purplish. All right, first row, second column, 2 times the negative 2, 7 times the 3. 2 times the negative 2, 7 times the 3. Third, I have already multiplied the first row times each of the 2 columns. First column, and then over here I did the second column. So now it's time to look at the second row. The second row in orange, negative 3, 1, is going to have to multiply by each of the subsequent columns. So, negative 3 times the 4 plus 1 times the 5. It's always plus in between. If when you multiply you end up getting a negative number, that's fine, but you still put a plus in between. So, negative 3 times the 4 plus 1 times the 5. And finally, I used black. I'm going to do the second row times the second column. Negative 3 times the negative 2 plus 1, second number, times the 3, second number. Right there. Now let's figure this out a little bit. 2 times 4 is 8. This is really 8 plus 35. And 8 plus 35 is 43. This is negative 4 plus 21. And when you add those, you should get 17. This is negative 12 plus 5, and that's where I get the negative 7. Positive 6 plus 3, and that's where I get the 9. So, remember, when you're starting this, now you do not need to write out all of this. What I would expect from you, if you were doing this manually and not using a calculator, is probably this. Maybe the green, maroon, orange, and black, or for many of you, you may just go right ahead and write the red, okay? With that, when you're multiplying and you say, okay, 2 times 4 is 8, 7 and 5 is 35, 8 plus 35. Whichever way, if you want to write these steps or this step, but then you can have your matrix set up and have your final answer. I just left this so that you could kind of follow exactly what I was doing. We did talk in class about how to use the calculator. I'm not going to do a video for how to use the calculator, but you can come in before the quiz or before school or whatever and ask if you have any questions. Okay, well that is matrices. First part, adding, subtracting, finding the dimensions, scalar multiplication, and multiplying matrices.